Welcome. In this lesson, we'll give our agents memory.
By the end, you'll know how to keep a conversation coherent within a session using short-term memory, and how to remember facts across sessions using persistent, vector-backed long-term memory. A raw language model has no memory between calls. Each request only sees what you put in the prompt. To make an agent feel like it remembers, we manage two layers ourselves.
Short-term memory holds the ongoing conversation. Long-term memory persists knowledge across sessions, stored outside the model and retrieved when relevant.
The naive approach replays the entire history each turn, but that blows past context limits and cost. Instead, we use a buffer window to keep the last few turns, a token budget buffer to fit a fixed budget, or a summary that compresses old turns. The best of both: keep a rolling summary of old turns plus the last few raw turns verbatim.
X. Here's the pattern in practice.
Each new message is appended to a recent list. Once we exceed the window size, the oldest overflow is folded into a running summary and dropped from the raw buffer.
When we build context, we prepend the summary as a system message followed by the recent verbatim turns.
This keeps token cost bounded no matter how long the chat runs.
Long-term memory uses the embed and retrieve pattern.
When something worth remembering happens, we embed the text and store the vector with metadata in a vector database. At query time, we embed the current input, search for the most similar stored memories, and inject the top matches into the prompt.
This is the same retrieval machinery as RAG, applied to the agent's own history. Quality matters more than quantity. Dumping every message into long-term memory makes retrieval noisy. Use a write policy that extracts only durable facts.
On the read side, rank memories not just by semantic relevance but also recency. Newer facts override stale ones, and optionally importance. The generative agents research popularized combining all three into a weighted score. Putting it together, each turn we recall relevant long-term memories, build a prompt combining system instructions, those memories, the short-term context, and the user input. After the model responds, we append the turn to short-term memory and extract any durable facts to write to long-term memory.
Recall, respond, remember, that's the cycle. In production, watch the token cost of both summarization and retrieval.
Memory often contains personal data, so isolate per-user namespaces, support deletion for compliance, and encrypt sensitive content.
Preferences change, timestamp everything, and prefer recent facts.
Finally, cap memory size and evict old or unimportant entries so retrieval stays sharp.
To recap, agents need two memory layers. Short-term memory keeps the conversation coherent, use a summary plus window to control cost. Long-term memory persists across sessions via embed and retrieve with a disciplined write policy.
Rank by relevance, recency, and importance, and always account for cost, privacy, and staleness in production.